The International Space Station will be deliberately crashed into the Pacific Ocean. After 3 decades of service and over $150 billion invested, humanity's greatest orbital achievement will be sacrificed to the sea. But here's what NASA isn't broadcasting on every news channel. They have no backup plan ready, no replacement station, no government-funded successor waiting in the wings. Instead, they're betting everything on a radical experiment that sounds more like a camping trip than cutting-edge space technology. Private companies are now racing to build space stations that inflate like balloons once they reach orbit. And if this gamble fails, humanity could lose its permanent presence in space for the first time in over 2 decades. Today, we're investigating MaxSpace, a startup that claims it can replace the ISS with a station that launches folded up like a parachute and expands to the size of a 3-bedroom apartment in orbit. Sounds insane? That's because it probably is, but it might also be our only option. Let's find out why. The International Space Station wasn't supposed to last this long. Originally designed for a 15-year lifespan, it's now celebrating its 26th year in orbit. And like any aging structure, it's falling apart. Metal fatigue, radiation damage, leaking air seals. In 2019, astronauts discovered a crack in the Russian Zarya module. In 2021, another leak in the Zvezda service module. In 2023, coolant leaks forced emergency spacewalks. NASA keeps patching these problems, but they know the truth. The ISS is living on borrowed time. Every year it stays operational, costs taxpayers over $3 billion. That's the price of keeping a crumbling orbital laboratory alive when its replacement should already be under construction. Here's the uncomfortable reality NASA won't say out loud. They can't afford another ISS. The original station took 42 separate launches, 13 years of construction, and contributions from 15 countries to assemble. The final price tag, somewhere between $100 and $150 billion, depending on who's counting. Adjusted for inflation, that's more expensive than the Apollo moon landings. Even if Congress approved the budget tomorrow, traditional construction methods would take another decade. We'd lose our permanent orbital presence during that gap. Research would halt, international partnerships would fracture, China's Tiangong station would become the only game in town. So NASA made a controversial decision: privatize low Earth orbit entirely. Instead of building and operating the next station themselves, they announced they would simply become customers. Private companies would design, build, own, and operate space stations. NASA would just rent time and facilities as needed. This announcement triggered a space race unlike anything we've seen before. Not between nations, but between startups and aerospace corporations. Axiom Space proposed attaching commercial modules to the ISS before it retires, then detaching them to form an independent station. Orbital Reef, backed by Blue Origin and Sierra Space, pitched a mixed-use business park in orbit. Voyager Space partnered with Airbus to design Starlab, a single launch station with an inflatable habitat. And then there's MaxSpace, a company most people have never heard of. No billionaire founder making headlines, no decades of aerospace heritage. Just a radical idea. What if we stopped thinking about space stations as rigid metal structures and started treating them like high-tech tents? Let me paint you a picture of the problem MaxSpace is trying to solve. Traditional space stations are built from rigid aluminum or composite cylinders. These modules are manufactured on Earth, which means their size is limited by the rocket fairing they have to fit inside. Even SpaceX's massive Starship has a payload bay only 8 meters wide. This creates a brutal constraint. You can only launch as much living space as you can physically fit inside a rocket. The ISS solved this through sheer brute force. 42 launches carrying dozens of modules that astronauts then assembled in orbit like the world's most expensive furniture. Assembly took over 160 spacewalks and 1,000 hours of extravehicular activity time. MaxSpace's solution? Don't fight the constraint, cheat it. Their Thunderbird station is built from advanced fabric materials similar to Kevlar, but significantly more sophisticated. These materials are folded and compressed during launch, taking up minimal space inside the rocket fairing. Once in orbit, the structure is slowly pressurized with breathable air. As pressure increases, the fabric unfolds and expands, growing from the size of a compact car to a volume of 350 cubic meters. For context, That's larger than the entire habitable volume of Skylab, America's first space station from the 1970s. And it launches on a single rocket. This is the question everyone asks, and it's the right question to ask. Expandable habitats sound terrifying. We've all seen balloons pop. We've all experienced air mattresses deflating overnight. The idea of floating in a pressurized fabric bubble hundreds of kilometers above Earth, separated from the vacuum of space by what amounts to really tough cloth, that's nightmare fuel. Here's what Max Space doesn't advertise heavily. This isn't some untested science fiction concept. NASA has already proven expandable habitats work. Since 2016, the Bigelow Expandable Activity Module, known as BEAM, has been attached to the ISS as a storage unit and occasional workspace. Over 8 years, it has survived radiation exposure equivalent to decades on Earth, temperature swings from negative 150 degrees Celsius to positive 120 degrees Celsius, multiple micrometeoroid impacts, and the harsh vacuum of space pressing against it 24 hours a day, 7 days a week. Not only did BEAM survive, it exceeded expectations. The soft goods structure proved more durable than rigid modules in some ways. When micro debris strikes a metal hull, it can cause catastrophic punctures or create secondary shrapnel inside the module. When it hits layered fabric, the material absorbs and disperses the impact across multiple protective layers. Think of it like medieval armor. A metal breastplate is rigid and strong, but one well-placed strike can pierce it. Chainmail is flexible, distributing force across hundreds of interlocking rings. Expandable habitats work on the same principle. Multiple redundant layers, each contributing to overall protection. So what exactly is Max Space proposing? Thunderbird is designed as a 4-person orbital research facility with 350 cubic meters of pressurized volume. Expandable designs create roughly 7 to 10 times more volume than rigid modules of equivalent launch mass. The station can be deployed in a single launch on medium-lift rockets like Falcon 9 or Vulcan Centaur. The interior is modular with reconfigurable workstations, sleep quarters, and laboratory space. Protection comes from multiple layers: an outer micrometeoroid shield, redundant pressure bladders, interior thermal insulation, and radiation mitigation materials. The life support system can operate for 6 to 12 months between resupply missions, and the entire station is designed for an operational lifespan of 10 years or more, with periodic maintenance. Here's what makes this architecturally significant. Traditional stations like the ISS are cluttered mazes. Walk through ISS footage and you'll see cables zip-tied everywhere, equipment bolted to every surface, storage bags velcroed to walls and ceilings. Astronauts often describe it as working inside a submarine that's been continuously modified for 25 years without a coherent floor plan. Thunderbird's design philosophy is the opposite. Because the interior volume is so much larger, there's room for dedicated utility routing. Cables and life support systems can run through designated channels instead of snaking across habitable space. Equipment racks can be repositioned without major surgery. The station can be reconfigured as mission requirements evolve. Nicole Stott, a former NASA astronaut with ISS experience, consulted on the interior layout. Her priority: making the station actually livable for humans, not just functional for experiments. That means proper handholds positioned where astronauts naturally grab, foot restraints at ergonomic workstations, visual separation between work zones and rest areas, small details that dramatically improve quality of life during months-long missions. Originally, Max Space positioned itself as a component supplier. They'd provide expandable modules that other companies could integrate into their station designs. But in 2023, NASA updated its commercial low Earth orbit destinations program, signaling that it would support multiple competing stations rather than selecting one winner-take-all design. This changed the calculus entirely. Why sell modules to competitors when you could operate your own station and keep 100% of the revenue? Max Space pivoted. Thunderbird went from being a product to being a platform. They would own it, operate it, and lease access to government agencies, research institutions, and commercial customers. This is the new space economy taking shape. Companies don't build infrastructure for NASA, they build it for themselves, and NASA becomes a tenant. Not everyone is convinced expandable habitats are ready for prime time. Critics point to several unresolved challenges. First, long duration durability. Beam has been in space for 8 years. True, but it's essentially a storage closet. No one lives there full-time. It's not subjected to constant human activity, equipment operation, and the wear and tear of daily use. Can these materials withstand a decade of continuous habitation? We don't actually know yet. Second, fire safety. Fire in space is one of the deadliest scenarios astronauts face. In 1997, a fire aboard the Russian Mir station nearly killed the crew. Fabric materials, even flame-retardant ones, behave differently under pressure in microgravity. Emergency response protocols for expandable habitats are still being developed. Third, repair and maintenance. If a rigid metal module cracks, you can weld a patch. If an expandable habitat tears, what's the repair procedure? Can astronauts patch fabric in the vacuum of space? MaxSpace claims their multi-layer design provides redundancy, but field testing under operational conditions hasn't happened yet. Fourth, the economics are uncertain. Building the station cheaper is only half the equation. The real question is demand. Who will pay to use these commercial stations? NASA's budget is shrinking. Pharmaceutical companies show interest in microgravity research but haven't committed billions. Space tourism is still niche. If customers don't materialize, even cheap stations become unsustainable. There's another factor nobody talks about publicly: China. While American companies debate expandable habitats versus rigid modules, China is steadily expanding its Tiangong station. They've already conducted multiple long-duration missions. They're open to international partnerships on their terms. If commercial American stations fail or face delays, the United States could find itself in an awkward position, reliant on China for orbital access. That's not just a scientific problem, it's a national security concern. MaxSpace has outlined an aggressive development schedule. Between 2025 and 2026, they plan ground testing of full-scale habitat prototypes under simulated space conditions. In 2027, they aim to launch a subscale test article for on-orbit validation. Between 2028 and 2029, they want to launch the full Thunderbird prototype with uncrewed operations. By 2030, first crewed missions should begin if all systems validate, and in 2031, operational handover occurs as the ISS is decommissioned. That timeline has almost no margin for error. Space development is notorious for delays, technical problems, funding gaps, regulatory hurdles. Any of these could push the schedule back years. If Thunderbird succeeds in low Earth orbit, MaxSpace has bigger ambitions. The same expandable architecture could be adapted for lunar surface habitats, launch compact, expand on the Moon, bury under regolith for radiation protection. Mars transit vehicles for long-duration deep space missions need volume for crew psychology. Martian surface bases would work similarly to lunar applications, but with atmospheric pressure considerations. This is the long game MaxSpace is playing. Low Earth orbit stations are the proof of concept. The real market is extraterrestrial expansion. If multiple commercial stations succeed, low Earth orbit in 2035 could look radically different than today. Instead of one massive ISS serving everyone, we might have government research stations leased by NASA, ESA, and JAXA for fundamental science. Industrial manufacturing platforms producing fiber optics, pharmaceuticals, and exotic materials. National stations operated by emerging space powers, and mixed-use stations combining research, tourism, and commercial activities. This distributed model has advantages: redundancy, specialization, competition driving innovation. But it also fragments capabilities that were once centralized. Ultimately, the success of commercial stations hinges on economics. The ISS costs $3 to $4 billion annually to operate. Can private companies deliver equivalent capabilities for less? MaxSpace estimates operational costs 60 to 70% lower than ISS due to simpler architecture requiring less maintenance, single launch deployment eliminating assembly costs, smaller crew size reducing life support expenses, and commercial efficiency versus government bureaucracy. If those projections hold, commercial stations become viable. If costs balloon or revenue disappoints, we're back to square one. Here quotes. What NASA won't say directly, but everyone in the space industry knows, we're in uncharted territory. For the first time since 1998, the United States is planning to operate in space without owning its orbital infrastructure. We're outsourcing our presence beyond Earth to startups and corporations. This could be the smartest decision NASA ever made, unleashing commercial innovation, reducing costs, expanding access to orbit, or it could be a catastrophic miscalculation that leaves America's space program stranded while other nations surge ahead. Max Space and its expandable habitat concept represent the boldest bet in this new era. Replace billion-dollar rigid modules with fabric structures that launch like parachutes and inflate in orbit. Trade the engineering certainty of metal for the logistical efficiency of soft goods. Hope that materials science and design innovation can overcome decades of conservative aerospace tradition. In 2031, we'll know if this gamble paid off. The ISS will plunge into the Pacific, ending an era. If Thunderbird is operational, humanity's orbital presence continues unbroken. If it's not, we face a gap that could last years. The age of government-owned space stations is ending. The age of inflatable commercial habitats is beginning. Whether we're witnessing visionary progress or reckless abandonment of proven infrastructure remains to be seen. But ready or not, the experiment has already started. The future of human spaceflight is being decided right now by companies most people have never heard of. Max Space is one of dozens racing to redefine how we live and work beyond Earth. Some will succeed, many will fail. The question isn't whether change is coming, it's whether we're prepared for what comes next.